Calculus video 3, example 1, using the limit definition of the derivative. So we're going to use the limit definition that we learned last class to find first of all, the derivative of our function. The function we'll be using for example 1 is f of x equals negative x cubed. So if you're picturing what that looks like, negative x cubed, kind of this shape here. What we want to know, so that's our function, that's our curve. What is the derivative function? So a function that tells us the slope at every point x along that curve. Secondly, part B there, what is f prime of 2? That is the slope of the tangent line at x equals 2. What happens when we plug 2 into that derivative function? That gives us the slope of the tangent line at that point. And thirdly, find the equation of the tangent line. And if I remember, we'll come back and kind of sketch all of that information on this curve. So let's start with our limit definition of the derivative. F prime of x is equal to the limit as h goes to 0, f of x plus h minus f of x over h. And I want you to know this formula. You should have this memorized, but also don't forget about what this means. The second portion here, right, the portion I'll draw here in red, that is the slope of a secant line. That's the change of y over change of x for a secant line. And what we're doing is we're taking that slope of the secant line and we're letting the h's get smaller and smaller. We're limiting the h's to 0, and that way the slopes of the secant line approaches the slope of the tangent line. Okay, good. So know both things. Know what it is, know the formula, but also understand what it's saying. So what we want is the slope at 2. So let me just kind of get a dot here so we can visualize on our graph. 2, if I plugged in 2, I'd get out negative 8. So on here, I'm at the point 2, negative 8. And I'm looking for, it's going to be very kind of vertical here. That's not a very good tangent line because I missed, but you get the point. I'm looking for what is the slope of the tangent line there, and then what is the equation of that tangent line at the end. All right, so limit definition of the derivative, f prime of x is equal to the limit as h goes to 0, f of x plus h minus f of x over h. We remember that our original function f of x is negative x cubed. Once again, that is going to go into, right, this f of x, this negative x cubed, is going to go right in there when we plug in f of x. The maybe harder part here is we need to know what is f of x plus h. That is negative, and every time I see an x, I'm going to put parentheses x plus h cubed. And we know that multiplying itself 3 times is to the third power, is multiplying it times itself, times itself, times itself. Now the negative sign is not raised to the third power, so that negative sign hangs out here. And we have x plus h, x plus h, x plus h. And the easiest way to do this is to do 2 at a time. So I'll take this first x plus h times this second x plus h. Again, just leaving the negative sign hanging out to the very end. So we have negative. The third x plus h is going to stay here. The first 2 get multiplied. That's x squared plus xh plus xh plus h squared. Which, after you do this a time or two, we remember that this is just x squared plus 2xh's plus h squared. Then we'll take that times x plus h. I'll go ahead and do that before I apply the negative sign. All right, the negative sign's still hanging out there. So now I'm going to distribute the x to all 3 terms of that first part. So that would be x cubed plus 2x squared h plus xh squared. Again, what I've done there is I've taken this x to all 3 of those. Now I'm going to take the h to all 3, and I'll have plus x squared h plus 2xh squared plus h cubed, all in parentheses, all times the negative sign. So basically everything here gets a negative. Negative x cubed minus 2x squared h. Oh, hold on. Let me back up. I see I have a few things in common. I have a 2x squared h and a 1x squared h. That can combine to give me 3x squared h's. I also have an xh squared and a 2xh squared. Those can combine to give me 3xh squared. And then I still have my x cubed out front and my h cubed here. Negative signs towards all those, so all of these should be negative here. Should be something like that. That is my f of x plus h. I like to find f of x plus h using side work like this before I start plugging it into the formula. If you try to do all this work within that formula, I believe it makes things more complicated, and I see more mistakes that way. All right, so the derivative, f prime of x, is equal to the limit as h goes to 0 of f of x plus h minus f of x over h. That is equal to the limit. Don't forget to keep writing that every time until we apply it. Negative x cubed minus 3x squared h minus 3x h squared minus h cubed minus parentheses negative x cubed all over h. And I said in the last video that everything inside the parentheses where you have the f of x term should cancel out with something from the f of x plus h term. And indeed, we see that the negative x cubed here cancels out with the negative x cubed there, which would turn to positive x cubed. So all those cancel out. Negative x cubed, positive x cubed cancels. And we get the limit as h goes to 0 of negative 3x squared h minus 3x h squared minus h cubed all over h. And this next step had better happen every time, otherwise it's going to be problems, but every term in your numerator should have at least an h in it. We have a negative 3x squared h is an h there, minus 3x h squared, there's 2 h's multiplied there, minus h cubed, there's 3 h's multiplied there. So we can factor out an h, again, leaving this limit here. Limit as h goes to 0. We haven't done that yet. We haven't let h go to 0. Factor out an h. That leaves me negative 3x squared minus 3x h minus h squared over h. And the 2 h's cancel. Therefore, we have the limit as h goes to 0 of negative 3x squared minus 3x h minus h cubed. And what we're seeing now, we're going to let h go to 0. So this is negative 3x squared, there's no h's there, minus 3x, we're going to let this h go to 0, get as close to 0 as possible, so we're just going to plug in 0, minus 0 cubed. And what we see is negative 3x times 0 is just 0, and 0 cubed is just 0, leaving us with negative 3x squared. And this is f prime of x. This is the derivative. That's part A, solved. This is the derivative of negative x cubed. The derivative function for negative x cubed is negative 3x squared. And what that is, this is a function. Negative 3x squared is a function that gives the slope of the tangent line at every value of x on the curve f of x equals negative x cubed. On that curve, negative x cubed, you pick any value of x you want. You plug that value of x into the derivative, and that will tell you the slope of the tangent line at that particular point. That's exactly what we want for part B. Part B says, what is f prime of 2? In other words, what is the slope of the tangent line at 2? When we see f prime, as opposed to just f, you're thinking the slope of the tangent line at 2. All we have to do there is take our negative 3x squared, but instead of x, plug in 2. That's negative 3 times 4, that's negative 12. what we're saying here is the slope of the tangent line at that point is negative 12, or if you would like slope to be a fraction, negative 12 over 1. If you go back up to the top, you look at our tangent line that I've drawn in blue, yeah, I'd buy that that would have a slope of negative 12 over 1, down 12, right 1. That visually looks right to me. So that's part 2. Part B, find the slope of the tangent line at x equals 2. We found that that was negative 12. Part C, find the equation of the tangent line. So that line in blue is a line, and we know two things. We know the slope, and we know the point there. If you go back up to the top, sorry for so much scrolling here, we see that point is 2, negative 8. And the way we got negative 8, remember, is we took our original function and plugged 2 into the original function. That gives us the y value. Now be careful because sometimes students get confused here. If you plug the x value into the original function, it gives you the y value. If you plug the x value into the derivative function, it's the slope of the tangent line at that point. Make sure you keep those two things separate. So the point we have for part C here, equation of the tangent line, equation of the tangent line, we know the slope is negative 12, and we have a point to negative 8, so I'll use the y minus y1 is equal to m x minus x1, so y minus negative 8 is equal to negative 12 times x minus 2. Distribute the negative 12, y plus 8 here. Negative 8 by plus 8 is negative 12x. That'd be plus 24. Subtract 8 from both sides. Y is negative 12x plus 16. That is the equation of the tangent line. Y equals negative 12x plus 16. Let me go back up real quick. Does that look right? Yeah, I'd buy that this blue line would cross the y-axis at 16. Looks like it has a slope of negative 12 from my kind of rudimentary drawing. Looks pretty good. Very good. If you want to kind of check your work, one thing you could do is go over to Desmos. Let's see here. Our original function is f of x equals negative x cubed. Looks like that. Better drawing than I had. Maybe zoom out just a little bit here. We have the point, well, you just do this, f of 2. Look, it tells you that it's at negative 8 there. So I can just make the point 2, negative 8. You can see that point there. If you want to check, did I get my equation of the tangent line right, just write your equation in. Y equals negative 12x plus, I think I said 16. And yeah, the blue tangent line there, if I scroll, really is a tangent line to the point to negative 8 on the curve f of x equals negative x cubed.